Welcome to a question in which we're graphing polar graphs. We're trying to match up these various polar equations to this, and this. 5 different ones. Okay, so how are we going to do this? Well, you don't have to memorize this. You just have to, I just want to expose you to polar graphs. Back when I was a student, I'm going to give you one of these old guy stories. Back when I was a student, we had to graph them by hand, all the little dots, the whole thing. But I just want you to have general exposure. So here it is. This is from the formula sheet, the notes I gave you. So this is at the top of Module 5 here on the Canvas course shell. Here are the notes, Part 5, polar graphs. So this will guide us. Okay, so how do we do? Notice that we have like numbers out here. So this one has numbers added. So 4 of these have numbers added. C has nothing added or subtracted, right? It's just 5 cos theta. So what's that? Well, see over here on the formula sheet I gave you, all the ones adding and subtracting are these kind of shapes. The ones that don't have adding and subtracting are just these two really is what we're going to deal with, or this one. Right, it's circles. The ones that don't have adding and subtracting are just circles. Now these down here are also no adding subtracting, but they're cosine 2 theta, 3 theta, 4 theta. That's not what we have. We have just regular theta with a 5 in the front, not on the theta. So that's this kind of equation, or this. So sine, it goes up. Cosine, it goes to the right. What do we have? We have it going to the right. That must be cosine. This one right here must be that one. 5 cos theta, right? That must be that one because it's going to the right, whereas the other ones are doing weird things. They've got that little dimple thing and inner loop and a kind of strange shape, another strange shape, a dimple thing. So those are the other ones. Okay, so we got the simple one out of the way. That's just a straight circle to the right. Check. Now, what about the other ones? Well, it's going to be all about whether these two numbers, they call in your formula, on your formula sheet, which is right here, on your formula sheet, they call the first number A and the second number B. And they say if A is less than B, it means one thing, one kind of graph. If they're equal, it means this graph. If A is greater than B, it means that graph. And if A is greater than 2B, it means that graph. So we got to go through it one at a time. So let's take A. I'm going to just kind of work over here with these guys. So for part A, says R equals 5 plus 5 cosine. Now they're the same. A, this is A, and this is B. A equals B. What did it say for A equals B? A equals B, cardioid. So meaning the little dimple hits the origin. See how this one has a dimple, but it doesn't hit the origin. See the difference in these two shapes? This one's dimple, the cardioid, hits the origin. This one's dimple doesn't. So the cardioid is the one that hits the origin. The little dimple hits the origin when A equals B. So A equals B. That's got to be that one. R equals 5 plus 5 cos theta. So we got A, we got C. Let's come on down to B. I'm kind of just getting lucky so far. The ones I start to work with are the ones that are there. I promise I didn't plan this ahead of time. This is just coming out lucky. All right, how about this one? I doubt our luck will continue. Let's see. So in this case, here's the A, here's the B. A is greater than B, right? A is greater than B. Let's see. If A is greater than B, what does that mean? A greater than B. Oh, well, there's 2 of them, huh? It's one of those 2. So it's either this one or this one. This one has a dimple, but it doesn't hit the origin. This one has no dimple. So it depends how much bigger A is than B. This one here says A more than double B, right? 2 times B. A is greater than or equal to double B, then it won't even have a dimple. Yeah, RA 11 is greater than or equal to 2 times B, 2 times 5, 10. So we're going to have one without even a dimple. Let's see. Oh, so it's going to be this one. So this will be our baby here. R equals 11 plus 5 cos theta, because the A is greater than or equal to 2 times the B. So it doesn't even have a dimple. Whereas this one over here has a dimple but doesn't hit the origin like the cardioid. This one's the cardioid because its dimple hits the origin when A and B are equal. See those differences in the formulas and stuff? All right, so now let me get rid of that. So that means there's got to be another one where A is bigger than B, but not so much bigger. Yeah, like E. See E down here? That's this. This must be E right here. R equals, I already forgot what it was. 7 plus 5 cos theta. So 7 plus 5 cos theta. Here's A, here's B. A is greater than B, but not by double. So if you look on the formula sheet, if A is greater than B, but not by double, it does have a little dimple. It just doesn't hit the origin like the cardioid does, and it's not more than double, so it's lacking in a dimple. It has a dimple, it just doesn't hit the origin when A is greater than B, but not more than twice B. So that's the case here. 7 is more than 5, but not more than twice 5. So therefore it has a dimple, but it doesn't hit the origin. That only happens when A and B are equal. All right, we got one more to go. What do we got left? It's this one, huh? Must be this guy here. R equals 2 plus 5 cos theta. This is the A, this is the B. In this case, the A is less than the B. That's it. A less than B. You get a limicon with that little inner loop. So that is the little inner loop we've got right there. So we matched them all up just using those notes.